Hello, everybody. Good evening. Welcome to the seventh session of The Joy of Coding here at Portland State University. I'm super psyched about tonight's class. We'll be doing what I think is a really fun and interesting and insightful activity about code refactoring. Um, we'll be working together to look at some really ugly code and try to figure out how to make it better, how to understand it, and how to apply tests to give us the security and the feedback that we need to try things. So anyway, it's going to be super, super exciting. But I also want to talk about the Project 3 assignment um, and uh, yeah, that'll probably be about all of our time. But as always, I want to start off with Prime Minister's questions. Our first project, our first phase of our multi-phase project is due next week. I've been seeing some really good questions come across the Slack channel, and had some good questions during office hours. A couple emails too. I think I owe people replies to. Sorry, I didn't get to that. Um, but what can I tell you? What would you like to know about either Project 1 or Project 2? Things are starting to get assigned here, so I want to sort of give everybody a heads up on what's coming. But what would you like to know? While you're still thinking about questions, there were a couple of things that came up during office hours that I wanted to review with you all. Let's see here. Um, oops. Yeah. So here in my Joy of Coding, which I have all the base changes. So one of the things that I realized uh, wasn't terribly clear is how exactly to use Maven. It used to be that I had like Maven like very early on in the course, and it was just kind of too much for the first week or two. So this term, we're actually not talking about. I don't really introduce the topic until next week, but I realize that might mean there's a couple of gaps in people's knowledge and understanding. So there are a couple of Maven commands that I just wanted to make sure that everybody knows about um, as you're working with your phone bill project. So if you look at the Project 1 assignment, actually, I just had up here closed. Let's see, did I move it? In Project 1. It talks about running the command line, and you run the command line with java-jar and then the name of the jar file. Just going to clean up my environment so I can show you all what some people have seen. So if I run it, you might get an error like this, saying unable to access a jar file target/phonebill.1.0.0.1.jar. And that's because, well, that jar file doesn't exist. Right now, I don't have a target directory. And even if I just run like some unit tests or whatever, I won't get the jar file created. To create the jar file, you need to run the mavenw package command. And in Maven, there are these various phases to your build. You can just say compile the code. You can say run the test, compile the code, and run the tests. The package the package phase will create the artifact that's produced by the build. In this case, the artifact is the jar file. And you'll notice that one of the last things that is here in the info is that it talks about the jar file and doing some things to it. You don't need to know the details of it. But now you'll see I have in my target directory. Target is where all of the intermediate files are stored. Or I say not intermediate. All of the built files are stored. Anything that's derived from something else gets placed here, including the phone bill jar. And so now when I run my java-jar command again, it prints out the main. It runs the main method, and as you may or may not recall, out of the box, all it does is it prints missing command line arguments to standard output. So if you're unsure or you're like, I don't know how to create this jar file so I can run the main method. That's how you do it. Use the Maven package command. I'm curious, was that, had people figured that out on their own? I can't remember exactly. I don't think I really talk about that in here. Do I? I talk about Maven verify, Maven site, but I don't really talk about Maven package, and I should. Yeah. Question, is print taking a description from the command line? What do you mean by print exactly, Daniel? And feel free to come off mute if it's easier. Oh, the dash print flag. Yes. So what's specified on the command line is a phone call, right? A phone call that has associated with a customer. So that's the customer for the phone bill. But then the phone calls, caller number, callee number, begin and end time. And when you say dash print, then the program, after parsing the command line and creating the phone call object, should print the toString value of that phone call. And if you implement everything else, you shouldn't need to change anything about the toString method. So yes, the description the description of the phone call is the value of the toString method. Daniel, did that make sense? Great, thanks. Let's see here. Ro had a question. Did you say build jar file or target file using package? It does both. So you can. So if you run the maven clean command, oops, you run maven w clean. The clean phase will delete all of the artifacts and compiled files or files that result from compiling something else. Essentially what it does is it deletes the target directory, right? I don't have a target directory anymore here. But then if I run really any command, I can say maven w, I can say compile, and all that will do is compile the code in source main Java. Well, source main, actually, if there are multiple languages. Right? So it's successful, it doesn't really do all that much, but now it creates a target directory, and inside that target directory, it has things like, okay, classes where all your class files live, and your resources. And I guess it also has generated sources. I don't even know what's in there. Okay, so the annotations directory. It doesn't really matter where all these things are. But yes, and so then that's what. So really, running any Maven command will create a target directory. But then if you run the Maven package phase, that will compile the source code, run the unit tests, and build a jar file. Again, all in the target directory. Or rather, it will output all of those generated things, like the class files, like a report that summarizes how your test ran, all that good stuff. And so now in our target directory, we got a bunch more stuff. We got these jar files, these things called surefire reports, which are outputs of from running unit tests. I encourage you all to explore these kinds of things. Let's see here. So yeah, here's the output of the tests. It basically says, yep, it ran tests in this phone call test class. There were 3 of them. There were no failures. Yep. So stuff like that. And so then you can consult those files to understand what happened during your build. And as we'll see on Wednesday, a lot of this plays into continuous integration and building sites for Maven projects, stuff like that. Cool. Okay. So those are just a couple more things that I wanted to highlight. Another question came in. Do we need to implement storing multiple calls, consecutive command line entries in program 1, just keeping them in collection? No, actually you don't. Now, to get things to, let's see here. If you want to call the add phone call method, you might need to implement, so if I go and I find my phone bill class, if you want to, if you want to call add phone call or get phone calls, you'll need to, actually, I guess maybe get phone calls. Yeah, you might need to implement these, which means we'll have a collection. But to be clear, nothing is being persisted to disk in project one. That's project two. Project two is all about writing stuff out to a file. Project one, it's all about command line parsing. And actually, you don't do very much in terms of the behavior of your phone bill. Don't worry, you'll do that in project two. So then, I mean, you could create a phone bill object. I don't think it's strictly necessary, but you could, and then you can add phone call to it, and you'll need to figure out how to store it in a collection of phone calls. But actually, if you can probably meet the requirements of project one without making any changes to your phone bill class. So please take that in consideration as you're planning your work. Any other questions about what's going on in class? Do the options only appear in slot 1 and 2? For project 1, that's correct. For project 2, there's a third option, so it'll be 1, 2, or 3. I think the takeaway is that all options appear before the first argument, which means that, let me just go back to the assignment, maybe it'll be a little more clear. If you see, as you're looking at the command line, if you don't see, if what you're looking at isn't dash print and isn't dash readme, then you can assume that it's the customer name. So meaning that all options appear before the first argument. So while it's true that it's slots 1 and 2 in project 1, it'll be 1, 2, and 3 in project 2, and as we'll see shortly, project 3 has more options. So an advice I gave someone in office hours is that, and this is something that I've seen lots of students do over the years, and it's really come back to bite them, is that they'll assume that certain, they'll make assumptions about, oh, the customer number is always going to be, the second argument in the string. Well, it's not, because print may or may not be there, and they end up with some really complex logic in the command line parsing for project 1, and it's really a struggle to evolve it for projects 2, 3, and 4. So instead, what I recommend is that people loop over the command line arguments instead, and say things like, oh, if the argument I'm currently looking at is dash print, well, set a flag that is for, says, oh yeah, print the thing that print the phone bill when we get to the end of command line parsing. Or say, hey, have I seen the customer yet? Oh, no, I haven't. Then this argument must be the customer, assuming it's not dash print or dash read. So I recommend that technique for command line parsing. It'll serve you. It'll make things easier in project 1. It'll serve you very well in projects 2 and 3. So here, another question. When we add a phone call, is the program supposed to keep running, allowing us to insert more phone calls, or is it just one phone call for each run? Good question. One phone call for each run. And to be crystal clear, I think I call it out here someplace, you do not read from standard inputs, right? So this isn't like CS 101 where you type things and hit return so you can learn about standard input. Nope, no standard input in this program class at all. Instead, you read things from the command line, from the command line arguments that are passed in as the one string array to the main method. So and actually this is true for all the projects. One invocation of the program, one invocation of the main method adds one phone call to the phone bill. So Daniel, to your second question, no, you do not keep adding phone calls to the collection until the program ends. For project 1, you can only have one phone call at a time. Project 2, when the phone bill is persisted out to a file and then read back in again in a subsequent invocation of the command line program, that's when you'll have multiple calls in your phone bill. These are good questions. Let's keep them coming. Let's see here. Should we use something like customer equals as part of the argument, or should we have it parse them in the intended order and make everything else null? You should not use customer equals as part of the argument. You should parse them in the intended order, but you shouldn't make everything else null. If there is a command line argument that is missing, it should be considered an error, right? So every time you invoke the program, all of the arguments are required. Options are optional, but all of the arguments are required each time that you invoke the program. I really like these questions and where you're going. What I encourage you to do is express them as integration tests, because you're talking about, hey, what's valid in the command line, and hey, does this come before this, and everything. Write an integration test for them. It'll help you explore what the requirements are. And actually, if you have a question for me, it's if you share your code with me, it's like, hey, I wrote this integration test. I assume it should have this behavior. Is this correct? I'd be happy to answer it that way. See, I'm not going to tell you exactly how to do it, but I'm happy to answer your questions about how you think it should be done. Okay. Anything else in people's minds? Awesome. Okay. Okay, project 1 is due on Wednesday before class. Last week we talked about project 2, which again is saving the phone bill out to a file. I want to talk about project 3 before we dive into the refactoring. Now, I fully acknowledge that most of your heads are probably still very much deep in project 1, but we only got so much time in the course. And so in order to pace things and give technically 2 weeks to actually more than 2 weeks to do the projects, I'm going to assign project 3 tonight. So in project 1, you wrote the fundamental classes to represent phone bills and phone calls. In project 2, you extended that capability to write the contents of a phone call, a phone bill, including its phone calls, out to a file and read it back in again. In project 3, you're going to, and the text file is a format of your choosing and it's meant to be read by a computer. It's not super pretty because the whole idea is that you can then have code that parses it back in again. In project 3, you're going to leverage Java's abilities to format text and work with dates to present a phone bill which is pretty, which is something which a human can look at and understand. So there are some new requirements that are coming in project 3, in the third phase. The first one is that you'll be now leveraging the get begin time and get end time methods of your phone call to represent the start and end times, beginning and end times of a phone call using instances of Java time local date time. So local date time is an object that represents, well, a point in time, a date and a time. So you'll be using that class to represent dates instead of just strings. And I'd like you to change the implementation of getBegin time string and getEnd time string to use the format method of local date time to format them, the begin time and the end time, using the short format style. And by the way, all of the local date time and all that stuff is explained in the Working with Dates and Text Formatting lecture that I hope you had an opportunity to review before tonight. But don't worry if you didn't. Please do so before you break serious ground on Project 3. So the whole idea there is that now we're representing dates and times using an object, not just a string. A specific object, and then if you go and learn about that object, you'll see you can get information about it, like, hey, what's the year, and how many minutes past the hour is, and and add 7 minutes to it, all sorts of great stuff. The local date time API is really cool. There's another new requirement that's coming in Project 3. So in Project 2, you could use any collection that you wanted to store the phone calls in a phone bill, and they were stored. They were stored however the collection chose to store them. So if you use something like an array list, it's first in, or rather they are they're added to the array list, probably appended them to the end. However, in Project 3, the phone calls should be sorted chronologically by their begin time. So one of the things that you'll learn about in let's see here, part of the Java Collections API lecture is that Java has this couple of facilities for sorting objects, and one of them is called Java Lang Comparable, which basically allows you to say, hey, when I have these two objects, here's how they should be sorted with regards to each other, right? Because some types of objects have like a natural ordering to them, like integers, right? The number 4 comes before the number 5, or strings, right? You can sort them alphabetically. Well, here we're going to provide a sorting algorithm that is inherent to your phone call. So if two phone calls begin at the same time, they should be sorted by they should be sorted chronologically first by their begin time. And if two phone calls begin at the same time, then they should be sorted chronologically by their caller. They should be sorted by their caller's phone number. If you have two calls that begin at the same time and have the same caller, then they're considered equal. We'll just keep the logic simple there. So anyway, that's the sorting logic. You're basically sorting on two fields, first on begin time and then by the caller's phone number. And I recommend that your phone call implement the comparable interface to make it easy to leverage the fact that certain types of collections will automatically respect the comparable interface. So in Project 3, you got to use local datetime, you've got to use comparable, and then the way this is expressed and the way these new features are leveraged are in something called a pretty printer. Now, a pretty printer is another type of phone bill dumper. In Project 2, you wrote the text dumper, which took a phone bill and converted it to a text format that could be read by the text parser. Here, the pretty printer is another kind of phone bill dumper that dumps it to a text format, but it's human readable, right? It's nicely formatted. It's something that a person can read and understand. To implement this, I recommend that you use the datetime formatter object to format your dates to make them look nice. And so not just the toString of the date object, you should use datetime formatter for that. And then also in the pretty output, it should contain the duration of each phone call in minutes. So another piece of logic that you'll need to add to your program. So you got those three new requirements. All of this is driven by a main method in a class called Project 3, which has all the functionality of the previous project. So the stuff from Project 1, the ability to parse the command line and create a new phone call for a phone bill. Everything from Project 2 to be able to read and write a phone bill's contents from a text file. And now there is a new option called -pretty, which will, if it's specified, will pretty print the phone bill to whatever is specified by the argument following -pretty. So if it's -pretty and the value of the file is dash, then it should write the pretty format to standard output. Otherwise, if it's -pretty, I don't know, pretty format.txt, right? Then it should write it to a file on disk. So the implication here is that your pretty printer, as far as the code goes, it ought to be able to very easily pretty print to either a file or to standard output. And I encourage you to study the hierarchy of writers, the Java I/O writer class, to figure out how to best have your pretty printer be able to handle potentially different output destinations for the pretty text. Bunch of notes about this project. Please pretty print the phone bill after the new phone call has been printed, right? Remember, each invocation of the program adds a new phone call. We want to see the newly created phone call in the printing output. Note also, and this is an important one, that the format of the dates and times on the command line is no longer 24-hour time, it's now 12-hour time. So this is a new requirement. And now, instead of there being only 2 command line arguments to specify a date and a time, now there are 3. Right? The first one is the date, the second one is the time in 12-hour time, and then the AM or PM comes after that. And some more footnotes. Oh wait, sorry. There was I guess okay. And some some more notes on error handling. Now all of the same, no, pretty much all of the same error handling requirements are continue from the previous 2 projects. So for instance, hey, if there's something missing from the command line, or you have extra command line arguments, or the format of the day and time is incorrect. Now it's a different format that it was, so you'll have to adjust your code to handle that. There's also a new error condition to test for, and that is if the phone call's end time is before its begin time. So basically, if we have a call that ends before it's supposed to begin. And note that we're going to ignore time zones. I did time zones last term, and it was dumb. It was just wasteful. So we'll just pretend that all the phone calls come from the same time zone. But you do need to check to make sure that the end time is before the begin time. So that's project 3, and are there any immediate questions that people have about the requirements or about how you might go about implementing it? Anything I can tell you now? Nope. Realize it might be a lot, so but please, I encourage you to, make good progress on project 1, so that you can start it on project 2 and project 3. This isn't due until the 31st, so you've got a couple of weeks to do it. But I wanted to give you a heads up now, so that if there's anything about these upcoming requirements that influences how you design and implement your project 1 and project 2, I wanted you to be aware. Okay. Okay. Now let's talk about code refactor. I hope you had an opportunity to look at the code refactoring slides or the accompanying screencast tonight. Code refactoring is a pretty advanced topic in software development. And while I think a lot of professional software developers know about it and sort of know what it is, the more I research about it, I realize there's a lot of discipline here, and there's a lot of tools for refactoring that is good to know about. So when you have software and you build something that people like, they're going to want more of it. Right? When you solve a problem, which is like hope you're here to do, and solve it well, people are going to say, well, great, can it also do this? Or like, oh, you know what? I see that it does this, can it also do this other thing? And so it's really important that your software be malleable enough to, sorry, there's a question that came in. Do we have the link? Yeah, it was posted in Slack, but I'll post it here in the Zoom chat too. Oh, there we go. Nice. There it is. You want, but in order to have code that can be changed and evolved, it must be easy enough to understand and to reason about and to work with, especially by people who didn't originally write it. And I think as you're starting to see in this course, working with other people's code takes skill, and there are things there are skills that you need to develop in order to be able to work with it. Now, there's as more and more over years of software development, there have been what are called code smells that have been identified that point to things that are awkward or unclear that can get in people's ways. So things like methods or variables with names that don't really express their intent, or duplicate code, or really complex if-then-else logic and loops and stuff like that. Now, luckily, these are pretty easy to spot. It's the kind of thing that most people can look at and say, ugh, that smells bad. That doesn't look right to me. You might not necessarily know how to resolve it or all agree on how to resolve it, but it's things that are pretty easy to point out. So what code refactoring does is it cleans up these smells, is that it makes the code easier to understand, easier to reason about, and easier to work with by really just improving clarity and making sure that the intent of the code is clear and that the relationship between the various parts of the code, the classes, the objects, the methods, and things like that, can be extended and can be worked with with the least amount of friction as possible. So hope this isn't the first time you're seeing this because of the code refactoring lecture, but there's another resource that I want to point you at, and that's this list of it's small. It's a list of code smells, and then some refactorings that you can do to remove it. And actually, I really like this handout. There's a lot of stuff here. It's actually kind of deep, but it helped me sort of understand the relationship between what is awkward in the code and is likely to impede me, and then what can I do to make it easier to work with. We'll come back to this in a couple of minutes. So the refactoring content in this course is actually comparatively new. I've only been teaching it for a couple of years, and I wanted to explain to people, but it was really hard for me to convey stuff in slides because refactoring is all about changing code, so that it inherently has motion to it. And it's like, well, the slides are pretty static. How can I show it off to people? But it occurred to me that I could leverage a code kata that's out there, developed by Emily Bache, who is just awesome. I highly recommend her channel on YouTube. She just has great technical content, explains things really well. It's fun. I'm a big fan. And I think one of the things I like the most about the content she's presented is this kata. And the thing I like about it is that it just hits home as like a professional developer, because it's like, I've seen this kind of ugly code so many times. It's the real world, right? Because what we're going to get is a code base that it's half implemented, it's got bugs in it. Oh, sure, there are unit tests. We don't really test anything, and then right, it's hard to read. It's really complex in places. And this kind of does a really good job of presenting that and then giving you an opportunity to make it better. And so that's what we're going to explore tonight. And this is how we're going to learn about code refactoring. We're going to work together to understand this kata, and then you'll go through and offer some suggestions of improvement, and then we'll implement it together. I'll be doing the coding up here, but I'll be looking to you all to really inform what we try and where we go with it. So I want to watch. She's got a really good video for it. And actually, I need to share the sound here because I didn't share correctly. Oh, great! We're not Autodesk users. And so, sorry, I'm going to stop sharing and reshare with audio. There we go. Skip the ad.
By my estimation, thousands of developers have tried the Gilded Rose Refactoring.
Hey, people who are on Zoom, can you hear the audio okay? I got a yes. Awesome. Cool. Okay, so yeah, this is like a 5-minute video. Let's watch this.
Kata. It's by far the most popular exercise on my GitHub pages, with over 4,000 forks. And I've got loads of translations in my repo, over 50 programming languages, most of which were contributed by other people. It's also included in the Arctic Code Vault, so it will be preserved for future generations of programmers to puzzle over why such a bad piece of code ever made it in there. Because fundamentally that's what this is, it's bad code. So why has such a strange little piece of code got so much attention? Hi, I'm Emily Bache, software developer and creator of Saman Coaching. In my channel, you can find content for technical coaches and lead developers. If you like what you see, please hit subscribe and like. This is the scenario. You have just been hired by the Gilded Rose establishment, which is a small inn with a prime location, and the previous developer, Leroy, has just moved on to new adventures.
Goodbye.
The goods sold in the inn are somewhat unusual, and the business rules governing their value are a little confusing. Your job is to develop the system further to support a new kind of product, conjured items. It's all a bit magical and fantastic, and it takes a lot of inspiration from the World of Warcraft, which I've never played, but I'm told all the characters come from that game. You don't actually need to know any of that to do the exercise. Basically, it's an information system with Byzantine business rules and a half-complete spec. Exactly what you're probably used to. So the code is not all that long, but just check out that indentation. We have a serious bumpy road going down there. The logic is, to say the least, tangled. And at first glance, it looks pretty difficult to change anything without breaking the code. Many developers have that experience daily with their production code. But the thing with this exercise is it's not real. So you can try stuff out and discover what works and what doesn't work in an arena where it doesn't matter if it all goes horribly wrong. Once you get the hang of a few refactoring techniques, you can actually clean up the code pretty quickly. So you go from, oh, this code is terrible, I can't change anything, to, no problem, I can fix this. Quite a short amount of time from one to the other, and that's why it's so fun. I didn't invent this exercise. It was originally presented by Terry Hughes in 2011 as a challenge to his colleagues. And I heard about it when Bobby Johnson wrote a blog post and put the starting code up on GitHub. I was intrigued. The code looked bad, and I like a challenge. The thing is, the original code was in C#, which at the time wasn't a language I'd done much work in. So I wanted to do it in Java or Python, my preferred languages at the time. And I didn't find it all that difficult to translate most of it. But the starting point was a little awkward to get a unit and test in place for, so I modified it a bit. And I think I simplified it and made it a bit easier to get going with the refactoring. As you know, I'm a big fan of approval testing, so I also took the time to add a suite of tests in my preferred approval testing tool, Text Test. And when I played with the exercise a bit myself, I thought it might be good to use this in a coding dojo, and I was doing one at the time, so I thought, well, okay, I need to set this up in CyberDojo, which is the tool we were using. It's still up and very useful. You should check it out. John Jaggett invented it. There's a link in the show notes. Anyway, to get it set up in there, I needed it to have a unit test and not text test. So I created just this single failing unit test and added it to the starting position. Having that test there, failing, it's like an open invitation to any slightly OCD programming nerd to come in, oh, I've got to fix that. And then you get drawn in. And I think that's part of the reason for the popularity of it. I really recommend having a go at this exercise. You can pick pretty much any programming language that you like, even UML or XSLT. Yeah, really. It turns out you can write really bad procedural style code in any programming language. And I'm constantly surprised by the pull requests that I get with translations. In fact, I'd like to take this opportunity to thank all of the contributors. So many fun and interesting programming languages. And if your favorite is not in there already, you could fix that. Send me a pull request. Before you do any refactoring, make sure you have some good tests. Either begin with the failing unit test that draws you in and write your own suite of unit tests, or you could try and work out how to use the approval tests that are there with text test. Then you can open the code in your best refactoring IDE, get stuck in. Happy coding!
Okay. So that's an introduction to it. That's what we're going to do. We're going to get a piece of code, we're going to inherit a piece of code, and then we're going to try to make sense of it. And we're going to leverage tests to help us understand the expected behavior. So if you want to play along at home, do so go to the Kata's repository and pull down the latest changes. The latest changes include a new, let's see here, that's not that, Kata's. There's now a Gilded Rose project in the Kata's repository, and it's got some code. It's got some really bad code. But it also has some requirements. So let's take a look at the requirements document here. Oops. Gilded requirements.txt. Okay, so this is what it's all about. Okay, so yeah, there's this. You're writing software for an inn that sells things, but over time the goods degrade in quality as they approach their sell-by date. Right, most things have an expiration date, or at least things that are sold here at the end have an expiration date. And so then they have a piece of software that keeps track of their inventory, and so you know what's expired, so you should throw it out. And again, the person who originally developed it, Leroy, ain't here anymore. So all you've got is the code, and no one to really talk to about it. So, and of course, they hire you as a new developer to work on this, and there's a new feature they want you to implement. So go implement the new feature. But here's how it works. Okay, so every item in the system has a value called sell in, which is the number of days that we have to sell the item. So the days before it expires. And then each item also has a quality, which says, well, okay, how good is it? How valuable is it? And so that's what's there in the inventory. And at the end of each day, the inventory system goes through and adjusts the sell-in and the quality accordingly. So a day goes by, so you have one less day to sell it before it expires, and then the quality also lowers because the day has gone by. Okay, well, so that's fundamentally what it's all about. But guess what? There are some exceptions. So once the sell-by date has passed, most items have their quality degrade twice as quickly after the sell-by date is passed. So before the sell-by date, it might go down by 1. After that, it might go down by 2. However, the quality, once it reaches 0, it doesn't get, they can have negative quality to it. It just stays at 0. Now, there are some exceptions to our rules, of course. There is an item called aged brie, right? Brie is a cheese that gets better over time. So actually, its quality increases as it gets older. But however, it never goes above 50, right? So that's the most quality thing you can have. Oh, and there's also something called sulfurous, which is a legendary item, and so its quality never decreases. It just always stays at its original quality. Oh, and then we also sell backstage passes, and they also tend to increase in quality as its sell-in date approaches. However, but then so like when but as you get closer and closer, it gets even more valuable. So when you are within 10 days of the sell by date of a backstage pass, the quality increases by 2, and when you're 5 days before the backstage pass to the show becomes is supposed to be sold, and then it goes up by 3. But after the concert's done, the backstage pass is completely worthless, and so it goes down to 0. And so here's like the new thing. There's this conjured item, which will degrade in quality twice as fast as normal items. And that's what's ultimately what we'd like to add to this. So okay, there's some code here. And let me just quick look at the code. I think it's over in the Gilded Rose. Let's see here, main, Gilded Rose. Here it is in all of its glory. And let's see, there's a couple more things. You can change the update quality method, which I believe is the update quality method. Oh yeah, you can update. You can change this one any way you like. That's great. You can add new code. Great, as long as you don't break anything. Oh, but the item class and the item's property you can't change because reasons. Apparently, there's a goblin that's going to get you, or you can't change that. But again, you can, but you can update the update quality. You can make changes to the update quality method, and and you can also, I guess, make some changes to the items, method if you want. Let's see here. You can never have an item increase the quality above 50, but sulfurous is a legendary item, and its quality is 80. It starts at 80, and it never changes. Okay, good to know. So if you're feeling a little confused right now, that's normal, because guess what? You've got like all this like business logic that is here expressed here in English, and now you got to make sure that it's adequately and actually properly represented in code. Okay, interesting. When I did this last time, we had a little bit more time to do it during class. And I had the students to understand the requirements, go through and brainstorm the given when then scenarios to help us understand these various kinds of items and stuff. And but since we don't have as much time to explore the requirements, I wanted to I just left the stuff from last time. So these are the kinds of tests that we need to that we'll need to implement to make sure that we're implementing those, that we're expressing those requirements appropriately. So, like for instance, if you have an item that has a sell-in value of 10 and a quality of 20, at the end of that day, then sell-in will go down to 9 and quality will go down to 19. Similarly, for aged debris, that starts with a sell-in of 2 and a quality of 0. At the end of the day, its quality goes up, so the sell-in goes down to 1 and the quality goes up to 1. And similarly for 2 and 50, since 50 is the max, it goes at the end of the day, it goes down to 1, but since it's reached its maximum quality, it stays at 50. So we've got a whole bunch of test cases here, and so this is really good. And actually, this is, I think, will help us get up to a much quicker start here, because this will tell us sort of what we have to implement in order to make sure that we can work with this code. Now, there's another test, and so then let's spend a couple of minutes implementing some of these tests in the Gilded Rose test. Oh, here is the here is that one failing test that she mentioned in the video. So I disabled it so that things would pass initially, but now when I disable it, I am going to say, let's see here. Now, foo, that's a terrible name for a test. I create a new item that has, let's see here, what is the items constructor? Oops. What is the items constructor? It takes the name of the item and then the sell in and then the quality. Okay, that's good to know. I'm going to go back to the test. So I'm going to create a new Gilded Rose that has that one item in it. I'm going to call update quality. And let's see here. It's saying that, okay, that the name of the first item is Fix Me. Well, that's not going to be true. So let's run foo and see what we got. Okay, it expected Fix Me, but was foo because this is the name of the item. Okay. Yeah, let's just get this one working. I don't know if it's a very interesting test case, but here's what I'm going to do. I'm going to take this value here. I'm going to put it in a variable so I can use it in two places. So I'm going to call it item name equals foo. I'm going to use it here. And I'm going to then use it here. Now I think that should work. Okay, good. This one's passing. I'm going to change its name. I guess item name is retained at end of day. It's a super dumb test if you ask me. It doesn't really test anything in terms of logic, but let's just make sure that it does that. So that it still works. All right. Well, now let's start implementing a couple of these test cases, these scenarios here, just so we can get familiar with the code. So this is a very common technique when working with code that you inherit. You can leverage tests to assert your understanding of that of the code, right? Yes, you can look at the implementation, but boy, I don't know about you, but it's going to be really hard for me to sort of figure out, okay, what are things actually supposed to do? So instead, I'm going to write a test to really help me debug things. So I'm going to start out with this first one. So I'm going to create an item with a sell-in of 10 and a quality of 10 and assert that at the end of the day, it goes down to 9 and 19. So I'm going to use this to, I'm going to use this just to sort of get some experience with the code. So I'm going to call this, I'm going to say, item quality decreases by one at the end of the day. So let's see here. I'm just going to start with, I guess, all this stuff. Oh, and you know what? So assert equals is like a plain old Jane way of doing it. I'm going to use hamcrest. Assert that. Apps.items.get name is equal to item name. Hamcrest. Nice. Okay, now I'm going to run this again just to make sure. Nice. Okay, that still passes. So I'm going to take all of this stuff and I'm going to use that as the basis for my test. Let's see here. Item name. I don't really care what the name of the item is, I don't think. And let's see here. Initially, its sell-in is of 10 and the quality is of 20. So the sell-in is 10 and the quality is 20. And then at the end of the day, I expect that the sell-in is reduced to 9 and that the quality is reduced to 19. So I don't know if this is going to pass or not. I expect it to, but I want to have this here for two reasons. First of all, to just to validate my understanding of the use case. Oh, good, it passes. And I also want it because I want to go in there and change this code. And right now, I'm flying without a net. Right? I don't have any unit tests to tell me whether or not I've broken anything. And this code is complex enough and likely fragile enough that, and I'm ignorant enough that it's going to, it's very likely that I'm going to get something wrong. So I want to have a safety net of a bunch of automated tests to make sure that I haven't broken anything. So, okay, that was the first one. Now, I'm not exactly doing test-driven development. As a matter of fact, I'm doing like the Bizarro test-driven development, right? Except Bizarro from like Superman comics, like there's like Superman and then there's like Bizarro Superman that like talks backwards and thinks bad is good and up and down. Right? We're doing test-driven development backwards. We're actually doing testing after the fact because the code's already been implemented, but we don't have any tests yet. So let's do that. So let's see here. I've written these tests, and I'm looking at this code, and I see some opportunities for cleaning it up, for refactoring some things. Like for instance, I've got like this logic right here, actually all of this stuff, where I create an item, and yeah, and then I assert something about that item. So I think I want to move some stuff into methods. I think what I want to be able to do is pass in like information about an item and then just have it return back the Gilded Rose object after already updating the quality. So what I'm going to do here, I'm going to make some variables here. I'm going to start refactoring. We'll talk more about refactoring later, but I'm going to introduce a variable and call it the item name. And then this one's going to be the, sorry, what was that? That was the cell in? Yeah. I'm going to call this cell in. I already had it. That was nice. And then this one's going to be quality. Nice. Told you I was smart enough to know that. Then I'm going to take these three lines and I'm going to move them into a method. Because I don't want to have this boilerplate in every single one of my tests. I'm going to say add item. And I want to replace both those occurrences. And oh, that's so much cleaner now. And a question came in. Because this is the repo, we need to push-pull from the pair programming stuff. We can't make changes to follow along with you, right? Oh, that is, well, if you make a branch, you could. So if you want to branch the repository to play along, great. Or you can just watch me as I commit stuff. That's a good point. So yeah, feel free to work on your own branch if you want. It'll conflict with mine, so it'll kind of be a throwaway branch. But yeah, if you want to play along too, great. Or if you've got ideas for what I can be doing, please follow along there too. Yeah. Yes, to extract the method, we'll see a lot of that later. But what I did was I selected some code, so code like this, and I went to the refactor menu and I said introduce or extract method. That's what I use to do that. And we'll be talking about all of this stuff here pretty shortly. Okay, my test passed. I'm going to commit this code, and I'm going to say added a unit test to verify the logic of the Gilded Rose Kata. Well, the update quality method. Okay. Okay, well, so that was the first one. I've got all these other test cases to explore. Well, let me just do one more. Let me do an aged brie. So let's see here. Aged brie. This is aged brie increases quality at the end of the day. Oops. I kind of want to move this one up. I'll move that up to the top there. And then test void aged brie increases in quality at the end of the day. Again, I have these really long test names because I believe it's clear. It's easier than typing a comment that explains all of this stuff. Oh, one more refactoring I want to show. I don't really need these variables anymore. It doesn't really, I don't think it makes the code any easier to read once you understand what the add item is. So I don't really want a declaration here. I just want to take this value and put it, just send it directly to the method. And I can do that by using a refactoring called inlining. I say inline variable, Poof, there it is. Now I can use a keyboard shortcut, which on the Mac is Alt Command or Command Option N. Cool. So now I just inline that there too. And I think it makes it a little easier to read. Okay, so aged brie. So I'm going to take this thing again. And this is going to be aged brie. Actually, is there a space in it? Yeah, maybe there is. Okay, aged brie. Good question. No, it's not really hiding the lines as much as it is just getting rid of them. It's getting getting rid of the thing on the left. I don't need the variable declaration anymore. I just want to take the value of that variable and put it into the method call instead. So just call there directly. I think this is a little easier to read. Right, it makes the code more concise. Yep. Nice, good questions. Thanks for asking them. So if we start out with an aged brie with a sell-in of 2 days and a quality of 0, at the end we should have a sell-in of 1 and a quality of 1 because it goes up. I have no idea if aged brie is implemented correctly or not. Oh, good it is. Okay, this is cool. Again, what I'm doing is I'm writing tests to verify my understanding of the problem, and to do it automatically. So then, as I start making changes to things, then I'll be able to verify quickly that I haven't broken any existing functionality. Okay. So let's see here. Oh, I'll add one more for aged brie because I'm really curious about the top. So let's see here. When it has a sell-in of 2 and a quality of 50. At the end of the day, the sell-in is 1 and the quality is still 50. So let's see here. I'll say quality of aged brie never exceeds 50. Okay. Aged brie, it was sell by 2. The quality was 50, and then the selling at the end of the day, it's I don't really like add item there anymore. What do I like? I want to say add item and update quality, and yeah, update quality. Oh, sorry, I just did refactoring and didn't tell you what it was. So I have a method here. I want to change its name, and so I want to go refactor rename, which for me is Shift F6. And then it says, okay, great, here's that method. What do you want to change its name to? So add item and update quality. And hit return. And notice it changed all the usages of it and its declaration up here, right? This is what refactoring tools give you. It allows you, it's smart enough, it knows the language and stuff, and so it'll do things like, well, I only have to change it one place, but yet it is changed everywhere that it's used. Okay. Nice. Okay. Great. Okay. Add some unit tests for H3. Okay. So we have a bunch of tests that will help us go faster later. But now I think it's time for a break. We've been going for an hour. So let's take 11 minutes. We'll be back at 7:15. And then what we're going to do after the break is that we're going to get together and you're going to look at the code and come up with some ideas, identify some code smells, and then present some ideas for refactoring it. But I think we need a little recharge first, so I will see you in 11 minutes. Okay, everybody, welcome back from break. I was just banging on a couple more of these tests, and I think I'll do the same while you're working in the breakout rooms. But, it's just an interesting experience to get this code and not really know how it works, but get to have these tests that can verify that, yes, It works. It expects as I behave. Yeah, right. It behaves as I expect right now, and this will tell me whether or not I've broken anything as I start to make changes. Anyway, test for those. Okay. So we've been working on this kata, which is all about this Gilded Rose Inn that has these items, and there's all this business logic about how the items age and what their quality is. And ultimately, we want to be able to add some new functionality to this. But I mean, let's look at the code in this Gilded Rose. It's got this one method, and as she pointed out in this video, there's like all this indentation here, and that's a pretty clear smell. But that's one of many smells in this code. And so then to help us get experience of identifying code smells, what I'd like to do is break out into small groups for a few minutes. Let's see how we do with, like, I don't know, 15 minutes. And identify some of the smells that we see in this code. So there are a bunch of code smells that are listed in the code refactoring lecture. There's also that cheat sheet that was there before. And of course, feel free to use the web to like discover some other ones. And what I'd like you to do is, again, look at this code that's in the Gilded Rose class, which I think this is a link. Actually, let me make sure it's a link to it. Yep, here it is here if you want to see it on GitHub, or if you're using IntelliJ, whatever. I'm going to break everybody out into some breakout rooms here in Zoom. But when you do, what I'd like you to do is populate this table with like, hey, what is it that you smell? So some of these have like well identified names, like duplicate code, or hard to understand variables. Talk about where you smell it. So like where in the code, like, hey, online, whatever. Where do you see it? And then what are some ideas for refactoring to make the code smell nicer, to make it so that it's easier to understand and therefore easier to extend? Any questions about what we're about to do before we break out into small groups? So let's see here, with 11 people, I will, let's break this just out into 2. Yeah, just 2 breakout rooms. And I'll let you choose which room you want to go to. And let's do that. So yeah, let's take 15 minutes and do that. Oh, don't have the room audio right. Let's see here. Okay. Okay. So then, let's take a look at what we got. Ooh, we got some good brainstorms. Does anybody have anything they want to say about what they just experienced the last 15 minutes looking at this code and thinking about smells? Any observations that you want to share? Anything that stood out as particularly, I don't know, insightful or surprising? Oh, there's a lot of if statements and it's hard to read. Yeah. Actually, let me bring the code up again here. Oops. Where is the rows? Yeah, lots of if statements. Hard to read. What makes it hard to read? Is there something that sort of said, gosh, what is it? Ooh, 40. Yeah, right. Yes, absolutely. I mean, Yeah, all that conditional logic. Oh my gosh. Oh yeah, yeah. Sarah observes that yes, there are so many things wrong. It's hard to know where to start. Exactly. Yeah, yeah. That's what makes it so challenging. And then Puya. Oh, the nested if statements. Yeah, I agree. And I think that's. I really like the way that Emily Bates put it in the video, where she just pointed out, it's like you've got this like this wave of indentation, and that right there is just like this very visual sign. You need to know what what the code does. You can just tell with like all these ifs, like, oh, it's making it really hard to read. At least the indentation's there, right? Imagine if like, if like there was like tabs mixed with spaces and everything like that, so it didn't look the same. Cool. Any other anything else people want to call out? Okay, so you identified all sorts of great smells here. Yep, duplicate code, and yeah, having primitives and everything like that. Yeah, yeah. Unoptimized operators, or just I think what that means is just repeating items.I like all over the place. Oh, good, good, good. Awesome. Cool. Well, we'll dive into each one of those later. But first, I wanted to talk a little bit about the tools that IntelliJ has for refactoring. Now, I've been using these all along, but this is where I hope after watching the content about code refactoring, things really start to make sense. So let's go through these in IntelliJ one by one. So here in the refactor menu, and I realize that if you've got like the newer look to IntelliJ, you don't always see the refactor menu, but if you just use refactor this, so Control T on the Mac, you'll get this pop-up menu. So you can do things like rename a program element, or so a class or a variable or whatever. Right, renaming is a very common refactoring. Change signature. Change signature is a pretty cool one. So you can like choose a method and then say refactor change signature, and it brings up this dialog that lets you do things like add parameters to it, and you can change its name here. You can change its visibility. Right, it just allows you to very easily change change your signature so that yeah, you can add a new parameter to it. And then there's the whole extract and introduce. So you saw me use this before for extracting a variable. And so like I'm guessing one of the things, like I bet someone suggested, hey, let's put items.I, which appears a million times here. Maybe we should put that into a variable. And so we can use that extract variable to do that. And similarly, you can extract things into a constant. Maybe we can do that with like this magic string right here for backstage passes. And and another one that I end up using a lot is by taking something and making it a parameter. So maybe you write a method the first time and there's always a particular value that's used. Well, maybe you want to make that a parameter that's passed in so that you can pass in different values. And then extract method, another really popular one that I use. We saw it with the tests, right, where we had the duplicate code. One of the go-to techniques for getting rid of duplicate code is to extract that code into a method and then replace the code that is duplicated with a call to that method. We may or may not see it tonight, but there are lots of object-oriented refactorings, things like, hey, making a superclass for this particular class, and then pulling members like methods and fields and stuff up to that class. This is one of the cool things about IntelliJ. Because IntelliJ knows all about your source code, it can make these changes and make sure that the change is propagated to all the places that it needs to be. Trying to do this with VI just makes it all the more error-prone. It's like, hey, did you find all of the method invocations or invocations of the method you just renamed? Now, luckily, a compiled language like Java will find it eventually. But having the tools take care of the heavy lifting helps you go faster. That's why we have tools. So anyway, let's see here. Yep, here's some more. Yeah, just things to look at. I encourage you to follow these links here if you want to learn more about all of the tools that IntelliJ has for refactoring and exactly what they mean. Okay, so let's use some of those tools now to get rid of some of these smells. So let's say I'm just going to go top to bottom right here. Okay, so duplicate code 20, 25, 31. Oh yeah, if items I quality is less than 50. Okay, nice. So yeah, let's have some, yeah, there it is. And there it is. Okay, oh, there it is. Oh, yeah, interesting. Okay. So yeah, so okay, good. We're going to start changing this, but first of all, I guess I want to check these tests. So I wrote a bunch of unit tests. I didn't write them all, so I don't. I just didn't have time to get to all of them. Oh, but all these still pass. I'm going to hide the ones that pass and just say, yep, everything's green. So we've got this test here, and there was another test that that she alluded to that I didn't go into detail. I do want to show that off real quick. Okay, so she mentioned this thing called acceptance testing, which the way it's been applied here is that there is a this test text fixture. So this is a main method that basically goes through and creates a bunch of test data, and then goes through and creates this test data, and then on the command line argument, you can provide a number of days that you want to age all these items by. And basically, the main method goes through and it prints out like this, comma separated. It prints out every item on that day. So as a matter of fact, let's just run this program now. Nice. Okay, so this is for 2 days. So you have all of these items. And here are the qualities and the sell in for each one of those items on day 0, and here they are on day 1. And this is also very common, right? You've got like a main program that you can interact with to further learn about how the program currently behaves. What I did is that I added an integration test that will exercise that. And then the kata. So Emily Bache also provided this, which is a file that contains 30 days worth of aging all of those things. I'm like, oh, okay, that's cool. So what I did is I wrote an integration test that invokes that main method with a value of 30, and it asserts that the output of running that main program is the same as the output of that was in that file that she provided. So the whole idea here is that in addition to my unit test, now I have an integration test that basically says, hey, listen, for that data, when you when you run it and when you age all those items for 30 days, yes, I get the same values. So between this integration test and my unit tests, this is what's going to give me feedback as I refactor the code to make sure I haven't broken anything. And while, as you might recall me saying from the lecture, refactoring isn't supposed to change behavior, but it can, because you're writing code, and you're writing code that's different. So having automated tests to give you rapid feedback helps you improve. It helps you go fast because you're confident that you haven't broken anything. Okay, let's start breaking things. So let's see here. Where is the Gilded Rose? I don't need this. I'll keep the requirements around if I need them. Can't change item. Gilded Rose. Okay. So yeah, some things that we've talked about. Let's extract ourselves some variables. So I want items I. Oh my goodness, it just drives me crazy that this thing is like repeated so many times. I want to extract this into a variable. So I'm going to say extract into variable. I'm just going to call it item. Please replace all 34 occurrences. That's insane. I'm going to call it item. Yay. Okay, I made a refactoring. I'm going to run my integration tests. I assume it's going to be the same. Yep, that was a pretty safe refactoring, but I'm going to commit this just so that I can just walk in baby steps. So introduce a variable for the item. is updated. Okay. So let's see here. And the next thing that you all were noticing is that this quality less than 50 is repeated all over the place. So here I'm also going to create a variable. And I'll use the menu again. And it's just the urge to use the keyboard shortcut. And oh, wait a second. Oh, it doesn't. It has to actually be an expression. I had the second. Wow. Place all 4 occurrences. Sorry, I had the paren in the selected. I didn't know what to do that. So I'm going to call it quality less than 50. Okay. Nice. And again, that shouldn't change much of anything. What are some other things here? Conditional complexity. Oh, the for loop can be simplified with enhanced for loop. If statement can be simplified, bang this or that instead of bang this and bang that. I'm not sure what that would mean. So maybe someone can explain to me like what they were thinking there. But yeah, let's oops, whoa, that broke something. What? Well, that's weird. Oh, can I not get a text comparison nicely? Well, maybe it's too big to do a text comparison. Huh. Well, that's interesting. That broke something. I'm genuinely surprised. But if let's make sure I got it right. So if I revert that, now it passes. Ha ha ha. This is the scary thing about this code, right? You think you're doing the right thing. You think you're doing something straightforward. And I mean, how did that even break? Oh, I know how that broke. Okay, okay. So like, maybe I'll ask you. So why do you think that extracting this into a variable changes the behavior of the program? And so, well, this is all 4. I just did them all, right? Why might that quality less than 50? Why does this break the code? Yeah, someone's weighing in at home. It tested the condition at the start and didn't recheck it. Yes. Oh, exactly, Sarah. Very, very good. Yes, that's why I think it broke it. So what we're doing is we're just saying it. We are comparing the quality to 50 up here at the beginning, but I bet we'll see that quality is updated. Yeah, gosh, quality is updated along the way and all sorts of times. So I don't think that refactoring is safe. But you know what? We found out in a matter of seconds that it wasn't safe because we had the unit tests, because we had the tests. And this is what tests give you, right? We found out right away that I did something that was more impactful than I thought. And that's fine. There's nothing wrong with that. But this is why I never refactor without tests. Okay, so that one, maybe not so much. Remember, there's a little bit more low-hanging fruit that that I want to pick. So let's see here. Primitive exception. Oh, so, something that I saw was that there are all these constants here, like age, debris, as much of places, backstage pass. So what I'm going to do is, these are like magic strings. So I'm going to put these into constants. So I'm going to refactor. I'm going to say introduce constant, and it recommends age, debris as a fine name for that constant. And so now what it does is it introduces a static right here for age debris. Same thing for this backstage passes to whatever the hell that is. I'm going to introduce a constant. Let's not call it backstage passes. Backstage pass. Nice. I'm going to call this thing sulfurous. Or sulfurous, I don't know. And see, for me, this just makes the code, it just seems safer to me. Sulfurous. Oh, look how much more narrow it is. Oh, that's funny. How come it didn't use the same? Uh-oh. Now I'm wondering like why this. Oh, it's funny. It didn't replace all the other usages of it too. Huh. Okay. Well, I'm gonna. Okay, I'm a little skeptical of now of things. So then I'm gonna run my my integration test to see if everything's. Oh, it does. That's good to know. I'm gonna pin that here so I can go back to it easily, and then I'm going to go back to my unit test. I'm gonna run all of these guys again. Because I haven't run this in a while. I probably should have. Oh, good, everything still passes. Good, I'm going to pin that here so I've got it for later. Okay, well, that's cool. Now I'm going to go through and replace these other constants with, or these other magic strings with the appropriate constants. This becomes sulfurous. And this becomes H3. And again, this shouldn't have any change. But then again, I don't want to make assumptions about things. Hey, you never know when there's a typo in one of these constants that's going to make a difference. I mean, I've made all these mistakes before, and so what I've just learned is that you've got to have tests so that you can go quickly. Okay, let's replace all those and run the unit test again. And you can go quickly safely. I mean, you can go fast, but then it's you're driving without a seatbelt, you're flying without radar, I don't know, you run the risk of things going bad. Okay, great. So extract some constants. Oh. Yeah, what I also want to do, so we're gonna, anyway. I'm also going to go back to my tests now because I also use those constants here in my tests. So I'm going to go, I'm going to replace the magic strings with H3. So now I can just say Gilded Rose H3. And I'm going to do a static import for this. So it just says H3. Oh, that's so much better. H3. Conjured item. Oh, no, wait, this one is disabled. So this one isn't supported yet. So I'm not going to have constant for quite yet. Passes. Oh, we found it. That's so nice. And then go back to pass. And so this is what you do with refactoring, right? You're sort of, you're kind of playing with your code, but I'm also exploring it. And for me, there's like this, it's me gradually taking ownership of it. All of a sudden, I'm understanding more. I use the test to understand what the code does from the outside, and now that I'm refactoring the code, I have a much better idea of what it's doing from the inside. So I'm going to run all those tests again. Nice. Okay, good. Use constants in the unit tests. Okay, pushing all that stuff up to GitHub. Okay, duplicate code. I don't know if there's anything we can do about this right now. For loop can be simplified with enhanced for loop. Oh yeah, that'll be a nice one. Gilded Rose. Yeah, actually, I mean, we should be paying attention to what IntelliJ is telling us. It is highlighting some warnings. So here it's saying a for loop can be replaced with enhanced for loop. Great, do that, please. Thank you, IntelliJ. And oh, where did it change there? Just some formatting, I guess. Okay, that's cool. Oh my gosh, it's so hard to read. And then what's the other warnings? Let's see here. Item.quality minus item.quality can be replaced with 0. Oh yes, please fix that. There you go. And that's it. That's all the warnings, and then there is some spelling errors. Okay, that's cool. Okay, well I fixed a couple of things, and again I'm going to use my tests to make sure that I haven't broken anything. And here's what right, baby steps. just go and make small changes. But all of a sudden, I mean, look, I mean, to me, the code is looking nicer, right? Already, it's like we're starting to see things that just get a little bit more tame, a little bit more understood. Okay, nice. Okay, remove things. Well, fix things. Fix things. IntelliJ warned us about. Okay. Woofed. Okay then. Well, okay. What do we got now? Conditional complexity. Yeah. For loop. Okay. If statements can be simplified, bang this or that instead of bang this and bang that. So what does that one mean exactly? Like this? Okay. So basically replace this not with, yeah, what you got to do this. You know what? Wait a second. I wonder if, can I do something like, okay, well, let's see what IntelliJ does. Um, oh, it does. Yeah, yeah. So it'll do that conversion for you. It'll say replace and with or, and I think it'll get it right. You can test to find out. Yeah, I don't know. Does that make it easier to read? I gotta admit that's, yeah, that logic just seems just as confusing. But if it's not that or that, yeah, I don't know. Yeah, just the whole thing is confusing. Um, hmm. What other ideas? Let's see here. Oh, there you go. Yeah, optimize. Yeah, use I plus quality plus plus. Yeah, like all those right there. All these times where you just add one to quality. Sure. So let's see here, and I can do that with I can do a search and replace. So code. I don't even know. Maybe it's edit, find, and replace. Okay. So I'm gonna replace that. I'm just gonna copy it on the clipboard with item.quality plus plus. Only two occurrences of it? No. Oh wait, it's minus one. Okay, sorry. Minus minus. There we go. Phew. That would have been a messy one. And then here, I'm going to replace this with item plus plus. There are four occurrences of that. Okay. Oh yeah, this is looking so much better. Run my test again. Okay. Cool. 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 Okay. And so then this is simplify, incrementing, and decrementing quality. Okay, this is looking so right. I hope you agree that the code is looking better now. It's still really wavy, but it just seems much more manageable now. Uh, so I saw that one of the oh yeah, we called out that one. Yeah, I think several people like said, hey, why don't we create some objects in this? Um, ooh, that's interesting. Yeah, let's spend a couple minutes trying to do that. So let's see here. What are some ideas that people had about how to apply objects to these things? Oh, nice. Weighing in, some weighing in. Abstract item class with an update quality method. Yeah, I like that. Yeah. Okay. And let's see here. I think one of the rules, and it's kind of dumb, is that we can't change the item class, but no one said we couldn't subclass it. So okay, yeah, let's do that. Um, yeah. Okay. And yeah, let's take aged brie. Well, yeah. What do you want to do first? What makes sense to do first? Maybe maybe there's just like a plain item. Yeah, maybe there's just like a plain item. Okay. Yeah. Ah. Okay. How about okay? How about this? Well, yeah. If item equals any of these, any of these, any of these. Also with an update quantity as well, and the same member as the abstract class. Yeah, yeah, yeah. I think yeah. I kind of agree. Okay. So then, yeah. So so okay, have all these items. Oh, item isn't final, is it? Oh, good, it's not. So we can subclass it. That's good to know. Okay, okay. So then I think actually the first thing I want to do is I want to take all this logic here and do I want to put it into a method? Maybe it doesn't make so much sense now. Okay, so I want to say the following. So then, um, so yeah, I want to have, okay, so then, yeah. Okay, I want to say, I want to introduce a new class. So I'm just going to create one. I'm just going to create one. I can create one up here. Someone at work showed me this trick that I really like now. You can go up here to this, at least on my IntelliJ, there's this a way to browse the sort of the files there, and if you right-click on it, you can say New Class, and it'll create a new class in that packet, which is really nice. So I think I want to call it plain item and updatable item. Maybe updatable item? No, no, let's just call it a plain item first. And this is, I want to add it to GitHub. Yes, thank you. And I'm going to have an extend item. Oops, extends item. And now it's red, probably because it matches the constructor or something. Yeah, no default constructor. So I will have it create a constructor that matches super. Nice. Okay. So now the plain item is going to have just the normal requirements. So like all of this stuff. So sell in equality at the end of each day lowers both values for every item. So what I'm going to do is I'm going to go back to my unit test now. Go back to my unit test. I'm going to find just the plain item. So yeah, like this one right here. Um, and now, well, like food, for instance. So, well, that's a lame one though. Add an item, update quality. Okay. What I want to do is, okay, I want to add a new one of these things, but I want to call it add. I'll do this one right here. Add plain item. So this isn't like something special like sulfurous or anything like that. And update quality. So I'm going to create. Oops. I'm going to create this method. This is what I want. It's going to return that. This is item name. Oh, that's lame. And then sell in and then quality. And let's see here. Oh, where did I just do here? Sorry, hit the wrong button. I want to move this up here. And I want basically, I want like most of the same code, but now I want to be able to pass in the item. Yeah, I want to pass in the item now. And so I am going, what I basically want is, well, I want to, okay, yeah, I'm going to do the following. I'm going to put this into a variable right here. I'm going to introduce a variable. I'll call it item. And then I'm going to create a new method with all of that code. So now I'm going to extract that into its own method, and I'm going to call it add item and update quality, just for a single item. And now I can, and actually I'm gonna inline. No, am I? Nah, I think this is okay readable. And now I'm going to have this guy return add update quality of a new plain item with the item name, with the sell-in, and the quality. So you see how I'm using refactoring here, where it's like, oh, okay, I know I need, you know, I don't want to duplicate this code again, although I suppose I could have and then refactored it. But instead, I want this convenient method that just adds a plain item with information. So that's what it does. It adds you know, the plain item. It creates a new plain item and then calls the same add item. The same way this one creates an item and calls add item quality. Okay, so let's see here. I'm going to run this again, and I expect it to fail because, well, I don't do anything interesting. Actually, maybe, no, I think it will pass because I don't have any special logic there. So, but here's what I'm going to do. I'm going to, oops, where's Gilded Rose? Gilded Rose. So here, I'm going to say the following. I'm going to say if item instance of a plain item, then I'm going to say, oh, I got to cast it to a plain item. Plain item plain equals plain item. Oops, plain item of item. And then I'm going to say plain.update quality, because yeah, I think it's Susan or somebody said, let's have a update quality method on the object instead. Now I'm going to add that a plain item. Yep. Now if I run my tests, it ought to fail because, oh no, sorry, it won't. I need to call update, and then I need to say continue because I want to go on to the next one. So the whole idea here is that while I'm refactoring, what I'm going to do is I'm going to gradually add the behavior that I want in these update quality methods. And eventually, I'm going to make all of this dead code here. Because I really don't want to mess with any of this code here. So I'm kind of re-implementing re-implementing all this code here as implementations of these update quality methods. So now I have the continue statement in there. Now I think it should fail because it doesn't go through all this logic anymore. Yes, it does. Okay, so now item quality no longer decreases by 1 at the end of the day. Okay, well that's fine. So now it should. So at the end of the day, this dot sell-in minus minus and this dot quality minus minus. So right at the end of the day, the sell-in and the quality decrease by 1. So I will run that again. Nice. Okay. Now I wonder if, yeah, so now if I run my other test, what will this do? This will probably still pass because in this test, in my main, in my test text fixture, Like for instance, this here is a plain item, and this here is a plain item. I don't know if I should change this now or wait. I want to leave these alone. No, I think I'll change this. So this is also part of the refactoring, right? So this is going to be a plain item. This is going to be age-free eventually. This is going to be a plain item. All of those are not. Oh, and then there's the conjured one that's not going to work. So actually, this will be a plain item eventually. Well, it'll sort of have the same behavior as a plain item. Okay. Oh, that broke. Oh, that broke badly. Oh, okay. I wonder why that broke badly. Are either of those not plain items? Oh, this is where I'm really not happy with the output of this test. Like, I have no idea what's different now. And unfortunately, I guess it's too big to present me with a diff, which sucks. I need to figure out. So if I'm going to use this, I need to figure out how to debug it better. So presumably it has something to do with. Okay, I'm just going to change the dexterity events. I'm going to make one change at a time and see if it breaks it. Again, though, right? Rapid feedback with the tests. Because otherwise, I mean, I don't know how to approach this thing. So let's see here. Dexterity. And again, though, this doesn't. 717. Oh, I know what I can do. Here's what I can do to make this easier. So I can go to this test, and instead of 30 days, let's just try 1 day. Oh, good. It failed in 1 day, and it's got so much. Okay. Let's just comment out all the other items to simplify this. And so what I'm doing here is I'm paring down my integration test. Oops. Oh, it doesn't. Oh, yeah. Stop. Undo. Put this on a new line. There we go. So what I'm doing is I'm leveraging this like big old test case to try to whittle down and figure out what exactly is wrong. And then once I do that, I can then write a unit test for it. And then so I'll get that. I'll write a unit test for it because again, I've discovered some functionality that clearly I don't have a unit test for. Okay. Oh, expected all that, but was. Oh, and now my. Okay. And so also my 30-day, which I closed. 30-day. Okay, so day 0, day 1. Yeah, can I? I'm just gonna delete all this. I really can't comment it out. So okay, good enough. Maybe this will sort of narrow things down enough. Now, because everything's in version control, it's easier for me to go to, oh, good, now I finally have click to see difference. Yay, okay. So 1020, oh, darn. Okay, so days 0 and 1 were fine still, okay? So now let's go to, so I'm going to have to do like a divide and conquer on this. So let's go for, I guess day 2? How many days did I? Why did that fail before then? Right, and so that's just a debugging problem. But I have tests that give me, again, really rapid feedback. So as I go to make changes here, again, what I'm trying to do is I'm trying to learn about all of this stuff. I'm trying to learn about it by capturing my learning in tests. And I have to have enough tests that I can explore all the various angles of it. So, okay, so day 2, does it start failing now? For the dexterity vest? Oh, actually, okay, so wait a second. Day 0 was, 1020. 9/19, and I guess it didn't do day 2. So, okay, now I'm confused. So like, right, and this is just me, okay, debugging, and it's getting late at night. So I'm going to just undo a bunch of stuff. So I just redid or I just undid my changes. I just reverted to what's there in GitHub. So now when I go back to that, and oh, maybe it didn't fail the way I thought it did because of all the other stuff. So actually, this was okay. So let's go to like 5 days, and um, yeah, 5 days for the text fixture, and see if this gives us anything interesting. So I'm going to then go back to the 30 days and only have 5 days of output and see if that tells me anything. Oops. Okay, so it's going to have some extra output. Let's see here. All of that, well, that's okay. So now I don't understand why it failed in the first place, because it looks like the dexterity vest stuff was perfectly fine. So there must be something that I'm missing here. I'm guessing it's pretty fundamental. And this is just me, flailing around, trying to debug things, and trying to get things to work. And so I'm going to go take a step back and revert my changes. Like that change there. And go back to 30, and just make sure that, yes, this really fails. Because again, I don't understand why this is failing, because I thought I implemented my plain item update quality. Oh, wait, it works out. Son of a gun. Right, wasn't that failing before? I hate when that happens. Because I know that we saw that fail. And this happens too. Sometimes where I got confused and there was something that, oh, no, because, okay, right, this passes now because it wasn't a plain item. Now when I change it to be a plain item, it fails at some point. Oh, I bet it's failing later on because, what? Because it doesn't bottom out at 0. Okay, so what I think is happening is that the quality ends up being less than 0, and I thought I had a unit test for that. Let's see here. So below 0. Okay. So I think that's the thing I need to do. So I need to write a quality of. I'm just going to put down here at the end. I'm going to say quality of item never drops below 0. Is that right? Yeah. So now if I have item that, oops, let's see here, if it has 0 and it's got 5 days left, selling to before, and the quality is still 0. So this is going to be my old school style is regular item. And so if I run this test, that passes. Okay, so now I'm going to have the same thing. But with a plain item. Quality of plain item never drops below 0. So add plain items, method quality. And so now if I run this fails because, aha, the quality was -1 instead of 1. Okay, so right, I forgot a piece of logic when I implemented the update method. I want to decrement it only if this .quality is greater than 0. Otherwise, if it's already at 0, don't bother decrementing it. And I'm going to run it again. Hey, that passed. So that gives me hope that when I run the 30 days of output one, now that there's a plain, oh darn, still failed, but perhaps for some other reason. Okay, but we're a little past time, and I think that's enough debugging for tonight. So I'm going to go figure this out at another time. But that's code refactoring, right? So the whole idea is that when you're given a piece of code, which is really hard to understand and hard to use, there are these go-to techniques that you can leverage to find the code smells, to improve them, so that you can then work on your code and make changes to it and understand it better. And I recommend you leveraging automated tests to capture that understanding so that you can continuously confirm and reconfirm that understanding as you modify things. Okay. Appreciate your time tonight. Remember, Wednesday, this coming Wednesday is going to be, after tomorrow, is going to be back in class. Oh, actually, sorry, it is optionally back in class for our second pair programming. If you want to be remote, fine, you can be remote. But I do encourage you to come, to be here in person with people. I think you'll find it's overall more compelling experience. But I'll let it be up to you. See you in a couple days, everybody. Thanks.